Okay, let's take the next question. And in this question, we are given a signal. So let us draw that signal. It's very simple. I mean, what we have basically, we are given a rectangular waveform. Okay, this is straight line here. So basically, this is basically 2 here. This is 4 here. And let's suppose the signal is x of t here. And this is your t. Okay, so now we need to check if this signal is energy signal or power signal. So it's quite straightforward. In this case, basically, since my signal is only between 0 and 2, so my limit is going to be between the 2 here, 0 and 2 here. Okay, so let's suppose the energy will be equal to, energy here in this case will be equal to, the formula was minus infinity up till positive infinity, x of t mod square into dt here. Okay, so you already know. So basically what we have, my signal, if you see here, from minus infinity up to 0 in this area, the signal here is 0 here. Okay, so if the signal here is 0, so it means from minus infinity up to 0, my signal x of t is going to be 0 dot dt here. Okay, plus we have another signal from 0 to 2. From 0 to 2 in this part, you can see from 0 to 2. The signal is basically a constant signal which has the value 4 here. So what we will say, that it's like basically 4 magnitude square dot dt here, plus after 2 up till positive infinity it's again 0 here. Okay, so it is basically integration from 2 up till positive infinity, it's again 0 divided by dt here. So obviously these two terms here are 0 here. So basically this is the only part we are doing the integration here. Okay, even you can do it directly here. Just to show you, I have done these remaining two integrations here. So basically what we will be getting here, we are going to have 4 square will be equal to 16. The integration of the constant will give me t here, and the limit is basically between 0 and 2 here. So basically I am going to get 16 and 2 minus 0, which will be equal to 32 here. Okay, so since this is energy, so you can represent them in the joule, and if you don't want to write the joule, so leave it. Okay, so the energy is 32. It means we got a finite energy here. So normally when you get a finite energy, it means that it is a energy signal here. It is an energy signal here. Okay, and I think normally you should stop here. But just since we want to calculate the power and all these things, so let us check that if my signal is giving me, if it is energy signal, the signal should give me the 0 power here. So let's check if it is giving me the 0 power or no. Okay, so in this case, I'm just going down here. The power will be equal to basically power. Power is equal to limit t tends to infinity 1 over 2t here. Basically, I mean, we have integration between minus t and t, but since, okay, let me write here minus t and t here, and it will be like x of t magnitude square dt here. Okay, so this was the formula for the power here. Now what we have basically, this is a time limited signal, means I have a signal only between certain limit here. So basically you can assume that the limit is from 0 to 2 in this case here. Okay, so if it is limit from 0 to 2, so basically the integration is going to give me the same value, which is 32 here. So I can have like limit t tends to infinity here 1 over 2t, and you can have 32 here, 32 here. Okay, so obviously anything like, let's suppose this is equal to 32 divided by, when I apply the limit, it will become 2 into infinity, so it will be infinity. So 1 over infinity here is 0 here. Okay, so basically I got the 0 power here. So for energy signal, we say that it should have a finite energy and 0 power, which is proved here. Okay, thank you.